Hello children, welcome back once again. Today we shall discuss about some topics which you have studied already in your 9th standard, in which first one is the atomic mass. Atomic mass also, as you have studied in your smaller classes, an atom having a nucleus in which electrons are revolving in a fixed paths, correct? And in which this is the nucleus, correct? In the nucleus there are protons and neutrons are present. So atomic mass is the total number of protons and neutrons present in the atom. Okay, the atomic mass or mass of an atom is actually very small because atoms are extremely small. Children, nowadays we have spectroscopy and all to measure exactly or accurately how much is the mass of an element and all. In olden times, there were actually no any that type of microscopic measurements to calculate the substances. So that is what scientists used to do is actually they relate the mass of an atom with respect to another atom. In olden times they used mass of oxygen. Oxygen's mass is actually 16. Oxygen's mass they consider as one of the relative atom because oxygen is found abundantly in almost all the substances. Oxygen is existing. That's why in the beginning they have taken oxygen as a reference atom. Later they taken a carbon-12 isotope as the reference atom, in which 1 AMU they calculated as 1/12th of carbon atom. 1/12th of carbon atom is considered to be one atomic mass unit, that is AMU unit. AMU means atomic mass unit. Okay, one atomic mass is actually the 1/12th of carbon-12 isotope. You should also remember carbon-12 is one of the isotope of carbon. And children, this 1 AMU unit is equal to 1.66056 into 10 raised to minus 24 gram. Okay, in terms of grams, if you consider 1 AMU is equal to 1.66056 into 10 raised to minus 24. Children, mass of an atom of hydrogen is 1.6736 into 10 raised to minus 24. So if you relate one in terms of 1 AMU, we will get the mass of hydrogen as 1.6736 into 10 raised to minus 24 divided by 1 atomic mass unit is 1.66056 into 10 raised to minus 24. Okay, in terms of grams, if you consider, these two can be cancelled. Okay, these are all in grams only. Children, you must remember, in grams, this is actually 1.6736 into 10 raised to minus 24 divided by 1.6056 into 10 raised to minus 24 gram. Okay, that is equal to 1.0078 AMU units. Okay, this is the relative mass, or we can say the mass of hydrogen atom in atomic mass units. How much it is? 1.0078 AMU. Okay, now let's move on to the average atomic mass. What do we have to find? Average atomic mass. What is this average atomic mass means? Children, in case of isotopes, you have studied that. Children, in case of average atomic mass means some elements like chlorine, carbon and all, they have different elements, means chlorine is found to be chlorine 35 also and Cl 37 also. Correct? And it is found that chlorine 35 is 3/4 part is found to be chlorine 35 only, and 1/4 part only chlorine 37. So if this is the case, then we can find the average atomic mass as average atomic mass is equal to how much amount percentage. 3/4 means 75%. 75% of 35 plus 37, how much? 25%. 1/4 means 25%. 25% of 37. Okay. 75% children, you know, 75% means 75 divided by 100 of means multiplication into 35 plus 25 divided by 100 into 37. Okay. So while calculating, you know, this is the 3/4 and this is 1/4. Okay. 4 is 4 comes as the LCM of these three. 3 35s are 105 plus 37. Okay, when you calculate, you will get this as 35.5 U. That is our average atomic mass of chlorine isotope. Okay, so 35.5 U is the unified mass or mass of an element of chlorine. Okay, that's why decimal places mass comes. Okay, when we calculate the average atomic mass of isotopes. Okay, children, you can also calculate the average mass which is given in your textbook as the same way by calculating the atomic mass of average mass of carbon. Next we have molecular mass. Already we have discussed about atomic mass. Let's discuss about molecular mass. The mass of a molecule is called molecular mass. Let's take the example of methane molecule. Methane contains 1 carbon and hydrogen. How many? 4 hydrogen are there. Correct? Now that is equal to what is the atomic mass of carbon? Carbon is exactly 12.011 gram. This is the exact mass of carbon atom. Okay, plus we have 4 into 1.008. Okay, this is actually the, you can write U or you can write U or you can write AMU units. Okay, so 4 into 1.008, 16.043 U. So children, what you have to understand is, what is molecular mass? Molecular mass is actually the mass of each individual elements present in the total mass of each individual element's mass. Next we shall discuss about another important term, that is formula mass. Children, one thing you have to remember, formula mass and molecular mass. Already just now we have discussed about molecular mass. Now we are going to discuss about formula mass. One thing only you have to remember, one difference only comes is in case of formula mass is used for ionic compounds. Okay, the mass of ionic compounds we calculate as a formula mass. That is the only difference from molecular mass. It is not a new concept at all. Formula mass means molecular mass of, we can say, ionic compounds. That is, if you take an ionic compound like sodium chloride, you know the mass of sodium is 23.0, correct? And mass of Cl is 35.5. Okay, when you add these two, how much you will get? We get a 58.5 U. So this is the formula mass of NaCl. Okay, children, the individual masses of each element is added. The only difference is that NaCl is an ionic compound. What are ionic compounds? When ions are joined together, like sodium lost its 1 electron to chlorine. so that Na positive and Cl negative is formed. So Na positive combines with the Cl negative, we get a ionic compound like NaCl. It can be KCl or any other compounds. Okay. So formula mass is the molecular mass of ionic compounds. Clear? So children, today we have learned about atomic mass. Then we also discussed some topics related to molecular mass and formula mass. Children, go through these topics and learn them. Okay? Bye.